Hey guys, today we're going to do 3-5 solving exponential equations. Your objective will be to be able to solve an exponential equation. First, we have one-to-one properties. So for an exponential function, f of x is equal to b to the x power. If b to the u power is equal to b to the v power, then u is equal to v. What are we saying? We have the same base raised to exponents, then the exponents must be equal. For any logarithmic function, f of x is equal to log base b of x. If log base b of u is equal to log base b of v, then u has to be equal to v. So we have the same base set equal to each other. U and v need to be equal. Solve the exponential equation algebraically. 20 times 1/2 to the x over 3 power is equal to 5. So first you need to isolate what is being raised to the power. So we need to isolate our base. We isolate our base by dividing by 20. And we get 1/2 to the x over 3 power is equal to 1/4. Now, I have no idea what x is going to be, so in order to do this, I'm going to log both sides. When we log both sides, I'm going to take x over 3, bring my exponent to the front, and I am going to isolate x now. So I have x divided by 3 times the log of 1/2 is equal to log of 1/4. Divide by log of 1/2. X over 3 is equal to log of 1/4 divided by log of 1/2. Multiply by 3. X is equal to, we plug into our equation log of 1/4 divided by log of 1/2 times 3 is 6. So what could we have thought about? 1/2 and 1/4 before we logged both sides could be written as a common base. The common base would be 1/2, and 1/2 to the x over 3 power is equal to 1/2 to the second power. So now that we have the same base, we set our exponents equal to each other. So x over 3 is equal to 2, which means x equals 6. Which way was a lot simpler? This way. What does that tell us? We isolate our base. If you can rewrite with a common base, that's what we do. If we can't rewrite with a common base, then we must log both sides. So let's try some more. This is 10. So if we're in log form, we need to go to exponential form in order to solve. If we're in exponential form, we're going to go to log form to solve. So 10 to the 4th power is equal to x. Therefore, x is equal to 1,000. I'm sorry, 10,000. Forgot one of the zeros there. Same thing, 2 to the 5th power is equal to x. Therefore, x is equal to 2 to the 5th power, which is 32. 4 to the negative 1st power is equal to x minus 5. 4 to the negative 1st power is 1/4 is equal to x minus 5. Add 5 to both sides.
Will the custodian please report to room 20?
So once I add 5 to both sides, I get 5 1/4, which is the same as 5.25. Here, once again, 4 to the 1st power is equal to 1 minus x. Subtract 1. X is equal to negative 3. We could also solve equations using a graphing calculator. So if we have this equation, ln of 3x minus 2 plus ln of x minus 1 equals 2 ln of x. In order to solve this, we need it to be equal to 0. So we make it equal to 0 by subtracting 2 ln of x. I graph it, and we can see that my function crosses the x-axis at x equals 2, which means my solution would be 2. I can check that. By plugging it in, but also I can replace 2 in all of these x's. So if I had the ln of 3 times 2 minus 2 plus the ln of 2 minus 1 is equal to 2 ln of 2. I get 6 minus 2, which is 4. ln of 4 plus the ln of 1. Adding tells me if I condense, I would get ln of 4 times 1, which is 4, which is equal to, if I take this and bring it back, ln of 2 to the 2nd, which is equal to the ln of 4. And as we can see, it works here as well. That's all.